Hello everyone, am I audible? Okay, I think there is a lot of noise. Let me see if we can deal with it. Okay, so is the audio good now? Okay, to my end, I think it is fine now. Okay, so there are a few people. Should we start or wait for more? If at any point you feel that the audio is not coming good, then please mention it in chat so that I can speak a little louder if required. But I think the audio should be fine now when I'm speaking at this pace. Okay, great. So let's start with the very first problem. The problem is find the maximum factor score of an array. The problem says that we have been given an integer array nums, and the factor score of an array is defined as the product of LCM and the GCD of all the elements of that array. And we have to return the maximum factor score of nums after removing at most one element from the array. And they are saying that note both the LCM and GCD of a single number are the number itself, and the factor score of an empty array is 0. So if you have an array of size 1 and you remove that element, then the factor score will be 0 for that array. And they are just clarifying that by LCM of A and B, they mean the least common multiple of A and B. And for by saying GCD, they are talking about the greatest common divisor. So let's say if the array is something like 2486, 2486, sorry, 816. If this is the nums array, then what we can do is either we don't remove any of the elements, or we can remove one of the elements. As we are being told that we can remove at most one element. So if we don't remove anything, then the array will be 2486, sorry, 816. If we remove one of the elements, then it can either be 4816, or it might become 2816, or if we remove 16, then the array can become 248, right? um I removed 2, I removed 4, I removed, okay, I didn't remove 8. So there is one more possibility, 2 4 16, right? So for an array of size n, there are n plus 1 possible arrays. When we remove at most one element, either the array will remain the same, or there will be n possible arrays of n minus 1 size where you would have removed one element. Now we are being told that we have to return the maximum factor score. So can I say that since we can remove at most one element, then we know that these would be the possible arrays which we can have after removing at most one element. We can just find out the factor score for each of these arrays individually, and whatever factor scores we got from them, we can just return the maximum one of them. Can I say this? So let's take an example. The factor score for the arrays, like factor score for any array would be LCM into GCD. है So for every array, we have to first of all figure out the LCM and GCD. So LCM would be denoted by blue color and the GCD would be denoted by green color for explanation purpose. So the GCD of this array would be 16. The LCM of this array would be 16 and the GCD would be 2. Then the LCM for this array is also 16. Then for this array is also 16. For this array the LCM is 8, and for this array the LCM is 16. The GCDs for these arrays are 4, 2, 2 and 2. So the factor scores for these arrays would be 16 into 2, that is 32, 16 into 4, that is 64. Here it is 32 and 16 and 32. The maximum one comes out to be this, so our answer will be 64. I hope it makes sense, guys. Yes or no? So in this problem, we just have to do this. Find out this maximum factor score, and the constraints in this problem are very small. So we can actually simulate this thing, like whatever logic we discussed on what we have to do in the problem, we can actually implement the exact same thing. N is less than equal to 100. So we can actually find out, uh, we can create these n plus 1 arrays, out of which one array is of size n and the other n arrays are of size n minus 1. And the overall time complexity would be something like big O of n square while generating all these arrays. And for every array, we will just have to iterate from left to right, find out the LCM and the GCD. And whatever is the product of them, we can just store it inside a variable, let's say answer. In this variable answer, we can just store the maximum one of them. So initially, let's say I stored 32. Then I went to this array where I have removed the first element. I calculated the LCM to be 16 and the GCD to be 4. The product is coming up to be 64, which is greater than 32. So I will set my answer equal to 32 now, and I will do it for each of these arrays. Does it make sense? In case if it makes sense, then we can move on to the code part. Please mention it in the chat. And in case if anybody has any doubt, then please ask. I'm waiting for your responses. Is this logic clear? We just have to implement the exact same thing. And let me take one more example, maybe this example 1 2 3 4 5. So in the example having nums array as 1 2 3 4 5, I think there will be a lot of possible arrays, or maybe not. So the possible arrays which you can create here are either 1 2 3 4 5 itself, where you don't remove anything, or if you remove one, then the array will be 2 3 4 5. Or if you remove um, 2, in that case the array will be 1 2 4 5. Or if you remove 3, then the array would be 1 2, sorry, if you removed 2, then the array was 1 3 4 5. If you remove 3, then the array will be 1 2 4 5. Similarly, you can remove 4 or 5. And then for each and every array, you can just go on to all these arrays, iterate over them, find out their LCM, find out their GCD. And once you are done with finding out the LCM and GCD, after that you can just say that the answer should be equal to the maximum of answer comma LCM into GCD. So let me show you the code. This was the function which we had to complete. So I'm iterating. Okay, for generating all these arrays, I'm running up a for loop of I for implementing this logic where you have to create all these arrays, possible arrays. I'm iterating over the array from left to right with I equal to 0 and I go less than equal to n. Basically, this I is telling the element you want to remove, and you can notice that you are having I go from 0 till n. है ना? So for all the possible values of I between 0 till n minus 1, you would be removing an element, and then you are having this I equal to n thing, which means that you are not removing anything. Now, if you want, you can just have a for loop from 0 till n and do it outside where you don't remove any element. This is the way in which I decided to write the code, that I index I will tell me the element which I want to skip. So other than that element, I'm putting up all the other elements in a vector with name A, and obviously this array A should not be empty. This empty valley line can come up in the case where you might have only one element in the array and you removed it. So in that case, the array would be empty. So I'm just saving myself from that edge case. After that, I'm calculating the GCD and the LCM. So I'm calculating the GCD and the LCM. Here you can use the inbuilt functions. After that, I'm just updating the value of answer as answer equal to the maximum of answer and L into G. And I'm returning the answer at the end. So I hope this problem is clear. Now let me give you a follow-up for this problem. Here n was less than equal to 100, right? So in the follow-up, I'm saying that let's say n would be something like less than equal to 1e5. What if n is something like that? There in that case, n square won't work. You will have to optimize this. By the way, right now we are not having n square. The time complexity is n square log n, because this GCD and LCM function takes log n time. So right now this is the time complexity, and it won't work if n was as large as 25. So you will have to optimize it using prefix sum and suffix sum arrays. Sorry, prefix and suffix arrays. Similar to prefix sum and suffix sum array, you can actually have prefix and suffix arrays for LCM and GCDs. So try to brainstorm on your own on how to optimize it. And the time complexity at the end should be something like big O of n log n. So this is a to do for you. Maintain a prefix, suffix, GCD, and LCM. Yeah, you can do that. So let's move on to the second problem. So the second problem says the name of the problem is total characters in string after transformations 1. This is the easier version of the problem, and the harder version came as the fourth problem. So in this second problem, it says that we are being given a string s and an integer t, which represents the number of transformations which we have to perform. In one transformation, each character is in s is replaced according to the following rules. If the character is z, then it becomes ab. If the character is anything other than z, let's say a or b or c, whatever, then it is replaced with the next character in the alphabet. So a will be replaced by b would be replaced by c, and so on. We have to return the length of the resulting string after exactly t transformations. So let me take one example. Let's say if the string is abcyy, if the string is abcyy, and we have to perform two operations, then after the first operation, a will become equal to b would be replaced by c would be replaced by d, y would be replaced by z, and this y would also be replaced by z, right? After another transformation, like this was the first transformation, we have to do two transformations since t is equal to 2. So in the next transformation, b will become equal to c will become d will become e, z will become ab, and the next z will also become ab. So the resultant string after two transformations would be this cde ab, and we have to tell like we have to return the length of the resultant string after exactly t transformations. So here the length is 7, right? Here the length is 7, so that would be our answer. And in the next example, they have taken AZBK. So A will become B, Z will become AB, B will become C, and K will become L. So the resultant string would become BABCL, which is having the length 5. So the answer would be 5. I hope the problem statement is clear. And the constraints are pretty normal here, or actually huge. S can be as large as 1e5 and T can also be as large as 1e5. So the first idea you might get in your mind is, let's say you had the string ABCYY. You will feel that, hey, I can just iterate over the string from left to right, whatever string I had S, and I can maybe create a new string with the name, maybe let's call the new string as str. In that string, while iterating over the first string, if I get an A, I will push a B here. If I get a B, I will push up a C. If I get C, I will push D. If I get Y, I will just push Z and Z. And once I would be done with transforming the string, then I will just say that S is equal to str. So basically, the string would be written here, and B, C, D, Z, Z. And I can do this thing t times. है ना? In the next transformation, you would just put up C at the place of B, then D, then E, then AB, and then AB. So it looks cool, but the problem is the length of the string can be as large as 1e5 and the transformations are also as large as 1e5. So there are already 1e10 iterations that you can see, and it would actually be a lot less, a lot more than 1e10, because the length of the string, this length of the string would actually increase after every few transformations, and it might increase in every transformation after having a lot of transformations already done, है ना? Because when you are doing a single transformation where you had a z, you are putting up ab, so the length of the string is increasing, and over time, as every character would one by one become z, and it would create new ab and so on. So you will have eventually all the characters with you. So it would actually be a lot more than 1e10. So yeah, with the current logic we will get a TLE. It won't work, but at least this is a good start. When you read the problem, at least you try to solve it, you try to think about something. Now, are we good till now? Please say yes or no in chat. Okay, so the thing is, the tricky part here which you have to notice here is, it doesn't really matter whether the string is bcdzz or it is zzbcd, or if it is bczdzz, है ना? As long as all the characters are the same, it doesn't really matter which transform, like in what way you permute it. Eventually the length will remain the same, and whatever string it transforms into, its length would also remain the same. Its length would also remain the same, right? Basically, order of characters does not matter. That's all you had to notice, and this kind of observation is very useful. It can solve a lot of your problems at the easy, medium, and sometimes even hard difficulty. uh, for hard difficulty it won't be just this much, but if you make this kind of an observation, that whether the order of elements matter or not, can actually simplify a lot of your problems. Like in this case, we realize that the order of elements does not matter. Even if I just had stored information like b is coming one time, c is coming one time, z is there one time, sorry, d is there one time, and z is there two times, this much information is enough. You don't really need to store the complete string. Now you see there will be at most 26 different characters. For each and every character you can keep its frequency. So now the transformation part is very simple. If you, let's say, had a string like AB or AABB, C, let's say C is coming up 100 times here, then D comes up 1,000 times, then you have at last Z coming up maybe 5 times. है ना? In this kind of a string, if you had to transform it into a new string, you would actually go for like over 1,000 iterations. है ना? You would have a for loop of over 1,000 size. And it could have been even more. Let's say D was coming 1e 5 times, sorry, 1e 4 times. It is coming up 10,000 times. So you would have 10,000 iterations, right? But instead of that, since we have noticed that the order of elements does not matter, we can actually store the information as A came 2 times, B is occurring 3 times, C is occurring 100 times, D is occurring 10,000 times, and Z is occurring 5 times. Okay. Now the transformation is really simple. You know that the number of times A was coming, it would become B. So B would occur 2 times, C will occur 3 times, D will occur 100 times, all these D will become E, so E will occur 10,000 times. Okay. And this Z will become AB. So instead of these 5 Zs, you will have 5 ABs. है ना? So A will come 5 times and B will come 5 more times. So B will come a total of 7 times. है ना? Can you see that this transformation is really simple? You just have 26 iterations here. You will just have to iterate over an array of size 26, or even if you create a map, that map will have the size of at most size 26. So now we can actually do all these t transformations. We can just have a for loop for size t, or maybe you can just say that first of all we can iterate over the given string and create a map. After creating the map, we can do this process of transformation t times. After doing it for t times, the total number of characters in that string after t transformations would be nothing but the number of the total sum of all the frequencies, right? So guys, does it make sense? I hope the problem is clear. This is the complete explanation for it, including the intuition on how I got this idea. Okay, great. So let's look at the code. In the code, um, first of all, I calculated the frequency of all the elements. Now, instead of using a map, I'm using a vector of integers of size 26. It's up to you. If you want, you can use a map as well. And after that, I'm having a for loop of size t. Basically, in every iteration, I have been doing a transformation. For the transformation purpose, I created a new map and a new vector of integers with name new count for now of size 26. Then for all the characters from A to Y, the transformation would be like, if you have an A, it will become equal to B. If you had a B, it will become C. So I'm having all the characters from A to Y. Right now for A, we are having the index 0. For B, we are having the index 1, and so on. For Y, we are having the index 24. For Z, we have the index 25. So I'm going from 0 till 24, and have been incrementing the frequency in that way. I created this simple method with name add, which will take two integers and add them. And if the sum is greater than the mod value, since we have to return the answer modulo 1e9 plus 7. So if the answer is greater than 1e9 plus 7, then it would reduce it. So basically, it will just make your code a bit cleaner, that you won't have to add two elements and then write the mod thing. You just call this add function. So uh, I'm transforming in this way. After that, once I'm done with all the characters from A to Y, then I'm just saying that instead of Z, I will have A and B. And after that, uh, this new count array would actually become my main count array. So I will just say key count equal to new count. And then the answer at the end would be nothing but the sum of all these values. So answer would be the sum of all the count I, and you can just return the answer at the end. So is it clear? And just for confirmation, is my audio coming good right now? Um, or is there a lot of noise or something? Okay, if it is coming good, let's move on to the next prop. Okay, there's one more thing. Sorry. The time complexity here would be, first of all, we are iterating over the given array. Let's say the length is n. After that, we have been iterating over, we have been doing the transformation, which takes big O of 26 times. There are like 25 iterations here and then these two. So basically, we are just calling it as 26. And this would happen t times. After that, we are having a for loop of size 26. So overall, we can say that the time complexity is something like n plus 26 into t, and the space is just big O of 26. So we can just say that we have constant space. Okay, nice. Let's move on to the third problem. The third problem is find the number of subsequences with equal GCD. The problem says that we have been given an integer array nums, and our task is to find the number of pairs of non-empty subsequences. Let's say the two non-empty subsequences are sec1 and sec2 of nums. So there should be these two conditions being followed. The conditions are, these two subsequences are disjoint, meaning that no index of nums is common in between them. And the second thing is GCD of the elements of sec1 is equal to the GCD of elements of the second subsequence. We have to return the total number of such pairs, and if the answer can be very huge, so we have to return it modulo 1e9 plus 7. So let me take one example. If you had a if you had an array like 1 2 3 4, I don't know why, but I can't paste it. Okay, this is also cool. Okay, so this is the given array 1 2 3 4. Now the possible subsequences which are disjoint. First of all, what do we mean by disjoint? If from 1 2 3 4, let's say you picked up a subsequence having these three people, then the second subsequence should not have any one of these. The second subsequence might have three, might not have three, but it cannot have any one of these 1 2 3 1 2 or 4, which have been coming up in the other subsequence. Okay. And the second thing was the GCDs of the subsequences which you have chosen should be the same. So if you had an array 1 2 3 4 and you picked up one in first subsequence like this, like one is picked up, and in the second subsequence you picked up 2 and 3, you picked up 2 and 3 in the second subsequence, then the GCDs of both of them would be 1 here, and the GCD of the second subsequence is also 1, which is equal. So this is a good subsequence pair. Okay. We have to count such pairs. So I hope one thing is clear here, that since we have to find out the total number of such pairs, um, or maybe we can just start on with a very simple thing. We can start with the brute force way. On if you have to just solve this problem and you don't care about the time and space complexity or anything, how will you solve it? What is this happening? Okay, there is some problem. I don't understand the logic of third problem. We have not discussed the logic part yet. Did you not understand the problem statement or something? We have not discussed the logic part yet. Anyways, let me tell you about the problem once again. We have been given an array nums. We have to find out the total number of pairs of non-empty subsequences where both these subsequences are disjoint with each other, means that there should be no element common in both of them, and the GCD of the elements of the first subsequence should be equal to the GCD of the elements of the second subsequence. So that's what we have to do. And okay, just one thing. Okay, fine, it is working now. So let's say you have a you have an array like 1 1, and if I say that, hey, this is my subsequence 1, this is my subsequence 2, then are these subsequences disjoint? Would you consider them as disjoint or not? This might be a doubt you can have. So in this case, this is disjoint. As long as the same element is not coming up in both the subsequences, it is disjoint. In this, the elements of different subsequences might be equal. That won't be a problem as long as these are two different elements. If I had said that these are the, like if I was picking up the same character in both subsequences, then it won't be disjoint. And for the part of GCD, it's clear, I think. So now the simplest way for solving the problem can be, you have an array of just one second. You have this array of size n nums, right? And you have to find out the number of ways in which you can have two subsequences, sec1 and sec2, such that their GCDs are equal and they are disjoint. So can I say that I will iterate, like I will just find out all possible pairs of disjoint subsequences, and then I will check for all those pairs one by one whether their GCDs are equal. Then check if the GCDs are equal or not. If GCD of sequence 1, let's call it as GCD1, equal to GCD2 or not. So what I mean is, if you had an array like 1 2 3 4, I will go on it from left to right. For each and every element, I will have three choices. Either I can push it in sequence 1 or I can push it in sequence 2. So since I'm having multiple choices at every position, I would use recursion here. For doing the brute force stuff, I would use recursion to find out all, like what will happen in all these possibilities. In first possibility, let's say I pushed the first element in sec1, so the sequence 1 became 1 and sequence 2 is empty right now. Then let's say on the next position, again I had three possibilities: either leave it, don't pick it in any of these subsequences, or let's say keep it in sequence 1 or 2. Maybe I kept this in the sequence 2. So in that case, the sequence 2 will become like this. After that, um, for the third element, you will have again three choices: either don't push it anywhere, or push it in sequence 1, or push it in sequence 2. So let's say I pushed it in the sequence 2. So the subsequence 2 became 2 3. And then for the fourth guy, I will again have three choices: don't take it anywhere, or take it in subsequence 1, or take it in subsequence 2. So let's say I this time chose this of not taking it anywhere. So in that case, once I would have iterated over the array, I'm having this these two as the subsequences. One of them is having just one element, and the other one is having 2 and 3. Their GCDs are 1 and 1, which are equal. So I can have a global variable with name answer, which was initially 0, and I can just increment it once because I have found one possible pair which was having all disjoint. Basically, the subsequences were disjoint, and you have the same GCD. And I can just backtrack and uh, check out the other possibilities for this guy. Once I would be done with checking out all the possibilities for this guy, like this guy could have been here or here as well, then I will move back to this guy and will check that if instead of pushing it here, if I had pushed it here or had done something else, then what would have happened. I believe you people would have solved at least a few such problems where you would have used recursion for finding out all possible pairs, है ना? Or you would have at least done a problem in which you just had to find out number of subsequences for something, and for every element you would have got two choices: either pick or don't pick, है ना? At least you would have done such a problem at least once, I believe. So this problem is a bit similar. In this case, you are having three choices instead of two: either pick, don't pick, or like either pick it in the first subsequence, or pick it in the second subsequence, or don't pick, है ना? You are having these three choices here. So I think the time complexity would come up to be something like big O of 3 raised the power n into n, something like this. Basically, a very bad time complexity. So, are you guys with me right now? Did you understand till this part? This was the complete brute force way. Here we are just using recursion. So, for implementing it, you could have maybe created a function, let's say with the name f. You would have something like index being maintained, because in the array you are iterating over the array now from left to right. So what is the index at which you are right now? You would have the main vector. Let's say the vector is with the name a. Then you would have maintained the two subsequences. You would have maintained sequence 1 and sequence 2 of, just to know which elements you have pushed in which subsequence. And every time you would have three choices: either don't do anything, so just go to index plus 1 with the same sequence, or go to index plus 1 but this time push the current element in sequence 1. So sequence 1 will have um, ai as well in it, the current element in that subsequence. Or do the same thing where you will just have that current element being pushed in the sequence 2, है ना? We are having these three functions being called, basically the recursion being called for these three people. So and you will have the base case here where you would just check if the index is equal to n. If the index is equal to n, in that case you will iterate over sequence 1 to find out the GCD 1. Similarly, you will find out GCD 2, And if GCD1 and GCD2 are equal, in that case you will answer say answer plus plus. है ना? So I hope the recursive solution, which is just complete brute force, is making sense. Okay, so somebody is asking a doubt related to second problem. I will discuss that once I'm done with this third problem. I will just discuss it. But for now, tell me about the third problem, the ones who are with me right now. Is it clear? Okay, great. So let's move on. Uh, let's try to optimize it. Even now, you should be able to relate this problem with DP, that you are able to solve the problem using recursion. है ना? Now you would be trying to figure out whether I can optimize it such that I can use DP here and turn the time complexity to be a bit simpler. So when you are iterating over the array, let's say you have iterated till this part, you have gone through the first I elements, and your sequence 1 and sequence 2 look like this. Sequence 1 is having maybe uh, 10 and 5, these two elements, and the sequence 2 has 25 and maybe 50, or maybe 25 and 105, something like this. So right now, do you really care about the elements which are there in the subsequence? At the end of the day, I only care about the GCD1 being equal to GCD2, है ना? So you might already have this, you can try to think about this, that can I somehow optimize my problem or optimize my solution by storing something other than the sequence? Like instead of storing the complete sequence, can I store some other information which would take up a lot less space, or take up a lot less space, and uh, it would still carry on all the information I require at the end. At the end, I only care about the GCDs now. So you would say, ki, yaar, I don't really need to store sequence 1 and sequence 2. I can just store the GCD of sequence 1 and GCD of sequence 2. That's all I care about. I don't really care about the specific elements I stored. So if I keep it in this way, then at the end of the day, okay, 1 second. Are you folks like, okay? Yeah. So at this place, instead of storing the complete sequences, we can store the GCD of the first sequence and the GCD of the second sequence, right? This will optimize the solution by a little bit. So right now what we have done is, our function which we had earlier, the function with name f, will now look like this. The function f will have the index, it will have the GCD1, and it will have the GCD2, right? And for the third thing which we had written earlier, a, like you can still have that as a parameter, but it won't change. So right now the only three things which will change when you call the other functions are the index, GCD1 and GCD2, right? This function will call the function index plus 1, because you will have this next guy being either taken in none of these subsequences. So you will have either the situation where you don't pick it anywhere, or you can pick it for the sequence 1, or you can pick it for the sequence 2. So if you don't pick it anywhere, then the GCD of 1 and 2 will remain the same, right? If you pick it in the first subsequence, then in that case your GCD1 will change. For now, let's call it as new GCD1. And similarly, if you pick it in the second subsequence, then you will have new GCD2. So the new GCD1 would be equal to the GCD of, um, let's say if you had the next element as 25 and you had pushed it here, so you would have got the subsequences 10, 5, and 25, how would you calculate its GCD? In general, if you had a subsequence and you had to calculate the GCD, you would have just said that find out the GCD of these two elements, which is 25, then find out the GCD of these two elements, so that eventually you would have got the GCD of all of these. You are already having the GCD of all the elements till now in this variable GCD1. So if I say that I calculate the GCD of GCD1 and the current element, then in this way I will get the GCD of all the elements including the new one. So guys, till this point, does it make sense on how we would be able to optimize our previous approach a little bit by using GCD1 and GCD2? Maybe not much in terms of time complexity and space complexity, since we are still having the recursion call being done for 3 functions here, but at least this will work. Guys, yes or no? In case if anybody has any doubt, then feel free to ask. I will try my best to clear it. Okay, so for finding GCD, is it some doubt or are you trying to say something else? Okay, time complexity. So even now, for each and every element, we are still having three choices, right? We are having 3 choices for the first guy, 3 choices for the next guy, 3 choices. Sorry. We are having 3 choices for the first guy, then again 3 choices for the next guy, then again 3 choices for the next guy, and so on. For every guy, we are having three choices. So you can try to relate it with the way we used to calculate the time complexity, where we had two choices for every guy. It used to come as 2 raised to the power n. So it would come something like 3 raised to the power n for this as well. You might have it as 3 raised to the power into n or something. Uh, like if you have something like big O of 3n into n, some people tend to just ignore the n. So you can call it as 3 raised to the power n as well. Basically, it's very bad right now as well. So we would have to optimize it. So now let's try to use this TP thing. So uh, in this given array, when you have traversed for the first I elements, let's say the subsequences. Okay, for now we are not maintaining subsequences, we are maintaining the GCD1 and GCD2. So let's say the GCD1 came as 5 when you had picked up the subsequence uh, 5 and 10, and for GCD2 the GCD is coming up as 5 when you have picked up 25 and 105 for subsequence 2, as we had just taken the earlier example. Now even if you had picked up 5, 10, and 25 in the first subsequence, this, or maybe 35 here, the GCD would still be the same, है ना, for a different subsequence as well. Right now the function um, f of I GCD1 and GCD2, where GCD1 and GCD2 are 5 5, would be called for this case as well, where you are having these two different subsequences, and for this case as well, where you are having these two as the subsequences, even though the GCDs are the exact same, है ना? And for whatever you do in the future, since these states are the exact same, these parameters are the exact same, whatever you do in the future would also be the same. So you would just do the same thing more than once. That is the redundant work, as you might be able to relate it like this. If maybe I can take a small example. If the array was, um, let's say, 1 2 3 4, and then there are 1,000 extra elements. So in one case where you had taken 1 in the first subsequence and 2 and 3 in the second subsequence, so you had f of 3 where you have considered 3 elements. The GCD of first subsequence is 1, and for the second one as well, the GCD is 1. So in this case, where subsequence 1 is 1 and the subsequence 2 is 2 comma 3, and yeah, let me change the example a little bit. Let's say we have considered 4 elements. We have considered 4 elements, picked up the first one in the first subsequence, picked up the next two in the second subsequence, and skipped the fourth one. So right now you have three choices. Either you go uh, whatever element you have here, let's say you are having 10 here, either you skip it. So in that case you would call the function f of 5 1 1, or you take it in the first subsequence. You will call the function f of 5 1 1 even now, because even if you take it in the first subsequence, the GCD will remain 110. है ना? Sorry, for the subsequence 110, the GCD will remain to be equal to 1. And even if you take it in the second subsequence, the GCD will still remain 1 for the second subsequence. So even the third function call you make would be 511. So right now what will happen is you will do all the computation for finding out the answer for this, then you will do the exact same thing for this, then you will do the exact same thing for this. So you are just doing redundant work here. We can save it by using dynamic programming. What we can do is, as soon as we are done with finding out the answer for this function, we will just store it in the DP array 511. So whenever this same whenever the function with same parameters is being called, you will just look into the DP array. You would see that, hey, the DP array is having some value, so I can just use this value, right? And you know that since these parameters were same, the answers would also be the same eventually. And like that was the main reason why we were able to put these parameters here. And now the next thing is we should define the DP state once. So the first parameter we had was index. The second one was the GCD of first subsequence. Let's call it as G1 for now. And the GCD of second subsequence. So we have 200 elements at max, and the values of the elements can also be at max 200. So we can create a DP array of size n and 201 and 201, because the GCD of multiple elements would always be less than equal to the minimum element, है ना? If you have two elements A and B and you take their GCD, so it would always be less than or equal to the minimum of A and B, right? Because for any element, its divisor, great GCD is nothing but the greatest common divisor, and the divisor of any element can never be greater than the element itself. So GCD must be either small or equal. So you know that these values would always be less than equal to 200, and this I would always be less than equal to n. So maybe you can say that we will create DP like this one, and we can define the state as uh, we have considered first I elements. Basically we can say DP of I, G1 and G2 equal to number of subsequence pairs. Okay, pen stopped working. Yeah, number of subsequence pair such that G1 and G2 are the GCDs of the subsequences. Are GCDs of subsequences. Okay. And we have considered the elements from 1 to I in this case. 0 to I minus 1 in zero based indexing. Basically, we have found the answer, found this thing for the first I elements. So eventually we will keep it till n. Eventually this I should reach n. I hope it makes sense. And you just have to do the exact same thing which we had been doing earlier. These transitions here will go to, like, you remember the transitions which we had. Either you don't pick, so the GCD1 and GCD2 will remain the same and index 1 will increase, or you can put the element in the first subsequence. So the new GCD for the first subsequence would be the previous GCD till now, and you will take its GCD with the current element. In this way, you can find out the new GCD for one, and you can do the exact same thing for when you want to put up the element in the second subsequence. And at the end of the day, our answer would be equal to dp of n I, where um, I will go from 1 till 200. So the overall GCD, like at the end of the day, you want to find out the number of pairs whose GCDs are equal. So the GCD1 and GCD2, these things should be equal. Now the GCDs can either be in the range from 1 to 200. If I is equal to 0, if the GCD is equal to 0, it means that the subsequence is empty. So we won't consider that case. Okay, so guys, does it make sense? Are you able to understand what state we will have and how we will make the transitions and the result part as well? And for the base case thing, um, initially dp of 0 0 0, this thing should be equal to 1 and everything else should be equal to 0. The only, like, we will start from this case now where you have not considered any elements till now, and the both the subsequences are empty, so the GCDs for both of them would be 0 0. So this would be the base case. We have discussed the base case here. We have discussed the dp state of what a state would carry. We have discussed the transitions, like the transitions we discussed earlier will be the same for now as well, and we did discuss the result as well. So just tell me how many of you are with me right now, and if you have lost somewhere, then please mention the doubt so that I can help you. From my end, I really did try my best to explain this as good as possible, and I really did take a lot more time than what we generally take for each and every problem. Okay, nice. The number of states we have got here would be 201 into 201 into 201, which should be around 8 into 10 raised to the power 6, which is good enough. And in every transition, like for each and every of these states, we will have three transitions. So we will have around 24 into 10e6 iterations, and we are taking the GCDs as well in each and every transition. So like overall time complexity will go like 3 into 8 into 10e6, sorry, 1e6 into में log of 200, because you would be taking GCD every time. So this should be the time complexity. It is like 2e7 into this thing should be something like 7 8. So the overall time complexity is going up somewhere around 1, or like from 1 to 2 8, basically 10 raised to the power 8 to 2 into 10 raised to the power 8. Like we are actually considering even worse than the worst possible case. In general, the time complexity should ideally be a bit better. So uh, this would pass. But if the constraints were even a bit larger, then we could have got TLE. So let's look at the code. In the code part, okay. So in my case, I have space optimized it as well. Like instead of creating a DP array with this much size, I created. Uh, I think I can't really spend a lot of time at explaining the space optimization as well. I would say that if you know about space optimization, then you would be able to understand my code. I have written iterative code. But if you don't know about it, then I would recommend you to look at the solutions which other people have posted on Leetcode. Leetcode has a discussion section. So just visit it out if you don't know about space optimization and you want the recursive code. Uh, it should be fine even if you look at someone else's code. The logic, like you would probably be able to find out a similar code. And for the ones who know about space optimization, it is like this is the current DP state, DP array, and this would be the next one. So I've named them as DP and NDP, and uh, maybe I can actually explain it like this. Like instead of having DP of I0, wait, uh, okay, so for now I'm gonna assume that you do know about space optimization. Even if you have watched only a few videos of Striver, then you would have got to know about it. If you don't know about space optimization and anything, then probably you can just go to Striver's DP playlist. He has explained it really well. Um, it is actually recommended as well. It would be useful for you in interviews as well. So probably you should watch a few videos of Striver if you don't know about space optimization. If you have done space optimization, then this should be pretty relatable. The states, um, after the space optimizations, instead of having DP of n, I'm just having DPII. Yeah, I think this might not be relatable right now if you don't know about it. That's why I'm getting a bit confused. Okay. Basically, for code, you can just look at the lead code discussion section to find out a code which you are able to relate with. And if you're not able to relate with my code, then please go to this discussion section. And for the ones who are able to relate it, um, I'm having the DP states as DPIXY, where you are telling that among the elements from index, among the first I elements, DPIXY will tell you the number of subsequences where the GCD of the first subsequence is equal to X and the GCD of the second subsequence is equal to Y. So I would write after space optimization it as DPXY, and the new possible state of DP, this is gonna be named as NDP. So we are having these three for loops for going to each and every of these states. Then for each and every state, we are having three transitions. If you don't pick up any element, if you don't pick up this element into any of the subsequences, then whatever number of ways you have to pick up, whatever number of subsequent pairs you can find among the first I elements with GCDs X and Y, you can just have all those pairs for I plus 1 elements as well. Like if among the first I elements you have 10 ways in which you can pick up sequence 1 and sequence 2 such that their GCDs are equal to x and y, then among the first 11 elements, all these 10 subsequent pairs are still valid, है ना? Because all these elements which you were taking from the first 10 elements, they are there in the first 11 elements as well. So this is the first transition. The second transition is the number of ways in which you would pick up this element into into a subsequence one. Then you would have the new GCDs. So these transitions are in that way that the GCD of uh, like currently the GCD were x and y. If you pick up this current element AI into first subsequence, then the new GCD would be GCD of x and AI, right? This will be the new value of x. So we are having NDP and the new value of x and y, and we are just adding this thing here. So this add function is the exact same as we had in the previous problem. It is if you don't like this, you can actually write it like this also. You can write the code as this as well, where we are just adding the number of ways of having these pairs, and you can do the transition like this for taking the mod values, because we have to return the answer with mod. And we are just doing the transition for picking up the element in the second subsequence in the exact same way. After that, we are updating the value of the DP, and then we have been uh, finding out the result, which is nothing but the sum of all DP of II, because both the subsequences should have the same GCD, and then we are returning the answer. So the time complexity here should be, this for loop will have n iterations, this for loop will have mx iterations, this will have mx iterations. So we are already having big O of n into mx iterations, where mx is equal to 200, and then all these three uh, transitions would go on. So the second and the third transition is also having big O of log n time complexity. This is going to have big O of 1 time complexity. So overall time complexity for this complete set of lines is big O of n into mx into log of the smaller value among them. So the smaller value would also be at least mx, है ना? So the time complexity would be something like this, and this is the worst to worst possible case. In general, your like this thing would be better than log of mx in general, but in the worst case, you can call it like this, and these two will remain the same. And instead of taking mx, you could have actually found the maximum element in the array, like const mx is equal to max element of a dot begin and a dot end, and you could have used this mx value instead of having a constant value of for mx, but in the worst case mx would be 200. Okay, so guys, is it fine? Does anybody have any doubt in this problem? Sir, iteration का base case dp 00 equal to 1 या 0? See, initially when you would start from the left, like initially when you would start, you would have considered no element so far, right? And your both subsequences would be empty, right? So their GCDs would be 0 0, है ना? So there is one possible way for reaching till this point. This is the starting point. That is why dp of 000 is 1. And you might have noticed it is like this as well, that whenever we have a problem related to finding out the number of ways and we are using dp, we generally declare all the, like we generally create all the states with value 0 initially, and all the states from where we can start, we declare them as 1. Such an easy, but I'm not able to write correct recurrence. Okay. Yes, please move on to the next one. Okay, okay. So guys, just please confirm once. Does anybody have any doubt in this problem? Okay, great. If nobody has any doubt, then let's move on to the fourth problem. Now, I was not able to solve this problem during contest, and this fourth problem is related to matrix exponentiation. So this is a bit advanced topic for like most of you as well, and I'm not good at it. At least for explanation part, I won't be able to explain it, and even for doing it for myself, I'm not really good at it. So I won't be able to explain the intuition part and a good way for solving it either. So for this problem, I would suggest you to look at the editorial for which would be provided by Leetcode. You can look at the solutions posted by others on Leetcode for this fourth problem. So we won't discuss it in the PCD for now. For D, can we use difference array technique? I don't know if it can be solved with difference array. It can be solved using matrix exponentiation, but I won't be able to discuss it properly. So I believe it would be better if you just look at the lead code discussion section. And I believe that the people who would be solving this problem would already be pretty good. Like if somebody is coming up to up solve this problem, then it means that you're already pretty good at DP and all. Probably the people would be somewhere around at least 1700, 1800, or maybe even more rated on code forces. So I think you people are already good enough to do it on your own as well. So skipping it won't be a problem. Okay, so mm, yeah, we can end the stream, I think, if nobody has any doubt. Somebody was asking a doubt related to the second problem. So are you still there? Can you mention the doubt once again and then I can explain it? In B, why not take mod 26, then analyze workers? I was getting, I had to skip this. I'm not sure why you're getting a WA. I won't be able to debug your code unless I see your code. So maybe you can message me on LinkedIn or Discord. And yeah, we can end the stream, I think. Can you check my code for a second? Yeah, you can send me on LinkedIn or Discord, or maybe you can send it in the TLE community. There will definitely be people who would help you, or you can send it there and ping me.